Welcome to the deep dive. So, when you think about conditioning or, cardiovascular health, chances are your mind probably snaps to just one thing.
That number, right, your heart rate.
Exactly. That single number. Is it 60? Is it 150? We kind of treat it like this oracle for how we're doing physically.
And according to the research, particularly Terence Hughes' work on the augmented circulatory system, that view is, well, it's profoundly incomplete.
Incomplete how?
Focusing just on heart rate. It's like, imagine trying to grasp the health of a whole forest.
Okay.
By just listening to one single tree, you miss everything else.
Mhm.
The roots, the soil, the way things connect and talk to each other, the whole ecosystem.
I like that metaphor, yeah. So today our mission is really to move beyond that single metric.
Right. We're doing a deep dive into what Hughes calls the augmented circulatory network. Turns out there are 6 integrated systems.
6 systems, okay.
And crucially, the neural architecture that controls it all, the intelligence running this show. Because health isn't just about the main pump. It's about distributed intelligence.
Distributed intelligence. Okay, let's unpack this.
Right. So let's start with that metric itself, the heart rate, BPM.
Mhm.
Beats per minute. It just tells you how many times the heart is beating.
Just the frequency.
Exactly. It gives you 0 context. 0 why. So say your resting heart rate is 65. What does that mean?
Would be good, right? Efficient.
Could be. Could mean you're in great shape.
Mhm.
Or it could mean you're actually deeply fatigued, maybe under-recovered from stress, and your system is just suppressed, hiding it.
Wow. Okay, so the number itself doesn't tell the whole story.
Not at all. It's like knowing your car's RPM. Useful, sure, but are you idling, climbing a steep hill, coasting downhill? You don't know just from the RPM.
Gotcha. The context is key. So the better question for, long-term health isn't just what's my heart rate.
It's more like, what kind of system am I actually building? What am I asking my body to adapt to?
Because it is always adapting.
Always. But not all adaptations are created equal, especially for longevity. There are really 2 main paths for how the heart itself adapts. Path number 1 is the good one, the goal. The volume-adapted heart. Doctors call it eccentric hypertrophy.
Volume adapted. How do you build that?
Through sustained, moderate intensity stuff. Think long walks, steady cycling, just extended periods of movement where you're not, like, redlining it.
Okay. Consistent, but not crazy hard.
Exactly. And what happens is the heart chambers actually get bigger. Your stroke volume increases, more blood pumped with each beat.
Ah, so it becomes more efficient.
Super efficient. Uses less oxygen for the work it does. Fills up better. That's the heart associated with longevity. That's what we want.
Makes total sense. Efficiency equals sustainability. So what's path 2? The less good one.
That's the pressure-adapted heart, concentric hypertrophy. This one's different. It's built by short, really intense bursts, especially against resistance.
Like heavy lifting.
Heavy lifting, especially if you're holding your breath, bracing really hard, that kind of thing. The heart wall thickens up to handle those sudden pressure surges.
Oh, okay. It gets stronger in a different way.
Stronger? Yes, but less efficient. It needs more oxygen to do its job, and that thickening can eventually make it harder for the heart to fill completely. So both are adaptations to stress, but only that volume-adapted heart is really built for the long haul, for low-stress operation.
That's a really clear distinction. But you said the heart is just one piece, right? The central station. What are these other parts? The 6 integrated systems.
Right. This is where we need to zoom out from just the pump and look at the whole architecture. The augmented circulatory system involves 6 interconnected networks working together.
Okay, lay them out for us.
Number 1, the foundation, the blood circulation network. That's the heart itself, ideally volume adapted. Then the arteries, they need to be flexible, produce things like nitric oxide.
Nitric oxide, right, for dilation.
Yep. Then the tiny capillaries, need lots of them for oxygen exchange. And finally, the veins.
And veins are different, aren't they? They don't really push the blood themselves.
Precisely. They're more passive, which brings us neatly to system number 2. The muscle pumps.
Ah, the second heart.
You got it. Especially the calf muscle. But really, muscles all over your body act as auxiliary pumps. Every time a muscle contracts, it squeezes those deep veins, pushing blood back up towards the heart against gravity.
So if you just sit still.
Those pumps are off. Simple as that.
Yeah.
Venous return suffers.
That's kind of scary when you put it like that. Okay, what's number 3?
Number 3 is one we barely think about. The respiratory pump. Your diaphragm.
Breathing. How does breathing pump blood?
Every time you take a good inhale, your diaphragm drops. This creates negative pressure inside your chest cavity. It literally sucks blood towards the heart.
Like a vacuum effect.
Exactly. And it happens, what, 12 to 20 times a minute when you're resting? It's a constant, gentle assist for the heart.
But if you're breathing shallowly up in your chest or holding your breath.
You switch off that vital pump instantly.
Okay, so that's 3 systems already heavily dependent on movement and good breathing. Now, number 4 really caught my eye. The joint articulation system. Moving joints helps circulation.
Absolutely. Think of every joint, from your fingerknuckles to your hip sockets, as a tiny local pump.
Ow!
When you move a joint, you compress the cartilage. That squeezes out the old fluid, like wringing out a sponge. Then, when you release the pressure, the joint draws in fresh, nutrient-rich fluid.
So lack of movement literally starves the joint fluid.
It stagnates it locally, yeah. If you don't move a joint through its full range regularly, that local circulation just slows right down. Desk workers, take note.
Wow, okay. So sitting still is bad for your joints and their local fluid exchange. What's number 5?
Number 5 is the lymphatic system. This is your body's waste clearance and fluid balance network. And here's the kicker. It has no heart at all.
No central pump for the lymph, so how does it move?
It relies entirely on movement. Muscle contractions, changes in pressure from breathing, the squeezing and releasing of tissues, especially that fascial network.
So if you don't move much, or move in very limited ways.
Lymph gets stagnant. Waste builds up. Systemic inflammation can follow.
Okay, that connects a lot of dots. And finally, number 6. You mentioned fascia.
Number 6 is the fascial network, that connective tissue web that holds everything together.
I always thought of fascia as just structure, like internal scaffolding.
It is structure, but it's also a major transport system for interstitial fluid, the fluid bathing all your cells. And it transmits forces. If your fascia gets tight and restricted, maybe from repetitive movement or lack of movement,
Fluid flow gets blocked.
severely impeded. The whole system kind of locks down. It restricts movement, which then further restricts flow. It's a vicious cycle.
This is a massive shift. It's not 6 separate things. Heart, muscle pumps, respiratory pump, joints, lymph, fascia. It's one integrated system.
Exactly. Deeply integrated. And what breaks it down, according to the sources, lack of varied, intelligent movement. Simple, but profound.
Which leads to the next obvious question. If you've got these 6 systems, what coordinates them all? How do they work together?
That's the intelligence layer. The source material calls it the neural tensegrity control architecture.
Okay, break that down. Neural is nervous system, brain.
Yep, and tensegrity. It's a concept from architecture, actually. Tension plus integrity. The idea is the body isn't like a stack of bricks. It's held together by balanced tension, mainly through that fascial network distributing forces everywhere.
Okay, balance tension.
And the critical wiring for this system, for smooth, coordinated movement, relies on what are called cross-lateral slings.
Those diagonal connections, like when you walk, your right arm swings with your left leg.
Precisely those. They run diagonally across the body. When those fascial and muscular slings are active and communicating well, movement feels effortless, integrated. The whole system flows.
And when they're compromised?
The system fragments. Coordination breaks down, and guess what has to pick up the slack?
The heart, working way harder than it should.
Exactly. It's compensating for the loss of all that distributed support.
Okay, so how does this control system get compromised? Hughes points out 4 big disruptions in modern life. First one, reductionist thinking.
Yeah, this is huge. We tend to view the body as just a collection of parts. Trained parts, not patterns, is how Hughes puts it.
Like doing bicep curls, but not thinking about how the arm connects through the shoulder to the core and the opposite leg.
Exactly. Fitness often focuses on isolated muscles. Medicine often treats just the symptom in one area. We miss the interconnected patterns.
So you can look fit in one way, like having big muscles, but the underlying system coordination might actually be pretty poor.
Totally. Which links to the second disruption, poor movement intelligence. We're often taught just mechanical execution.
Yeah.
Do 10 reps like this.
Not how to feel the movement, explore it, adapt it.
Right. Modern life just doesn't encourage that kind of multi-directional exploration. We sit in chairs, walk on flat surfaces, stare straight ahead. Those cross-lateral slings, they often just go dormant.
Okay, third disruption, over-adaptation, getting stuck in a groove.
Yeah, specializing too much. Could be your job. Sitting at a desk all day reinforces one pattern. Could be your sport fitter. Think a runner who only moves in the sagittal plane, straight forward and back.
So your tissues, your fascia, even your neural pathways become really good at that one thing.
But rigid and inflexible for anything else. You lose variety, you lose resilience.
And the fourth disruption is maybe less obvious, injury and illness.
Right. Any kind of trauma, a fall, surgery, even just chronic pain creates guarding patterns.
Hmm.
Your body tries to protect the injured area.
Makes sense. You tense up.
Exactly.
Yeah.
Physically and neurologically. The nervous system remembers, it keeps the score. This often leads to chronic restrictions, maybe in breathing, and pushes the system towards sympathetic dominance, that fight-or-flight state. The architecture is locked down for protection, but it's not flowing freely anymore.
That context really clarifies the difference between healthy effort and damaging strain, doesn't it?
Huge difference. Effort is working hard within that coordinated, supported system. Strain is pushing for output when the support network, those six systems, isn't online or integrated properly.
And that strain is what forces the heart into overdrive.
Right. And we see this strain manifest in three really common patterns, things we probably do every day without realizing the circulatory cost.
Okay, what's the first pattern of strain?
Mechanical strain. This is basically the Valsalva maneuver, holding your breath and bracing under load.
Doesn't have to be a huge weightlifting max out, right?
Not at all. It could be bracing just to stand up from a low sofa if you're stiff, or straining on the toilet anytime you hold your breath and bear down.
And what does that do systemically?
It instantly slams the brakes on the respiratory pump. Venous return plummets. You get these immediate, sharp spikes in blood pressure inside the chest and head. Do that repeatedly.
And you're driving that pressure-adapted heart change, the less healthy one.
Exactly. That's a primary driver. Okay, second pattern, temporal strain.
Temporal. Time-related.
Yeah, think blasting to readiness. This is when you jump straight into intense exercise without a proper warm-up.
Guilty as charged sometimes. Just want to get it done.
We all do it. But think about what's happening. Your heart rate jacks up immediately because you demand intensity now. But the rest of the system, the muscle pumps aren't fully active yet, your breathing rhythm hasn't synchronized, your joints aren't lubricated.
So the heart is trying to deliver, but the support crew hasn't arrived.
Perfectly put. That breathless, slightly nauseous, almost ill feeling you sometimes get at the very start of a hard workout. That's often your heart desperately compensating because the network isn't ready.
It's the heart doing the work of all six systems before they're online, so readiness isn't a switch you flip.
It's a conversation. Needs maybe 10, even 20 minutes to gently bring everything online together, not a sudden command.
Okay, and the third strain pattern?
Cessation strain. This is stopping abruptly after intense activity.
Like finishing a hard run and just stopping, hands on knees.
Exactly. Or hopping off the treadmill and immediately standing still. What happens?
The muscle pumps just stop working.
Instantly. Blood starts to pool, especially down in your legs because gravity takes over. Venous return drops like a stone. The heart is suddenly left without all that pumping assistance it was just relying on.
And that can make you feel dizzy, lightheaded.
Or worse. It puts acute stress on the heart. That's why a cool down is crucial, not just for muscle soreness, but for circulatory stability. You need 5–10 minutes of gentle movement to allow the system to gradually rebalance.
Wow. So mechanical, temporal, cessation strain, what's really striking is strain isn't the same as intensity.
Not at all. Strain is intensity without support. It's uncoordinated effort.
Which leads us nicely to the solution Hughes proposes, this wave protocol. Because as you said, a lot of traditional cardio, like just running or cycling, might miss pieces of this.
It often does. It's usually very linear, sagittal plane, doesn't necessarily use full joint ranges, might not stimulate the lymphatics much, can sometimes even encourage poor breathing patterns if you're straining.
So wave whole system activation, augmented circulation, varied patterns, extended practice is designed differently.
The whole idea is to inherently avoid those three strains while addressing all the layers, the mechanical pumps, the structure like fascia, and the neural coordination.
And the core principle isn't just pushing harder.
No, the core principle is progressive integration. The real driver for long-term healthy adaptation isn't necessarily peak intensity, it's duration and consistency of integrated movement. Overload comes not from just jacking up the heart rate, but by increasing engagement across all six systems.
Okay, how does that work? You mentioned 3 types of integration.
Right. First is spatial integration. Spatial means space. So instead of just moving the big muscles, you consciously bring in the peripheries. Move your hands, feet, spine, head, fingers, toes.
So you're activating more of the body.
Exactly. Which means you're activating more muscle pumps and articulating more joints. This increases the overall demand on the entire network, but without necessarily causing huge spikes in cardiac stress because the work is distributed.
Clever. More systems working together shares the load. What's second?
Temporal integration. Temporal means time. Simply extending the duration of your sustainable practice. Maybe you start with 5 minutes of continuous varied movement. Then you build to 10, 15, maybe 30 minutes or more.
Why is duration so key?
Because it takes time for those crucial adaptation signals to really kick in. Things like sustained shear stress on artery walls, which signals nitric oxide release. Capillary growth takes time. Getting prolonged benefit from the muscle pumps requires sustained activity. Short bursts don't provide the same signal.
Okay, duration matters. And the third?
Pattern complexity. This is about variety. Moving in multiple directions, not just straight forward and back. Using twisting motions, reaching, bending, spiraling.
Things that force you to use those cross-lateral slings.
Precisely. It retrains the nervous system, wakes up dormant pathways, and naturally helps re-coordinate breathing with movement. You can't really do complex flowing movements well if you're holding your breath or bracing.
It sounds like simplexity. You follow simple rules, move continuously, vary the patterns, breathe naturally, and out of that emerges complex, intelligent movement.
That's exactly it. The system starts to self-regulate. You're providing the right environment for all 6 systems to optimize themselves together.
Which must change how we look at our fitness data, right? Like the numbers on our watch.
Totally. Stop obsessing over the absolute heart rate number. Start looking for signs of system intelligence in the data.
Okay, give us examples. What are these new metrics?
Well, first, look for system support. When you're doing continuous coordinated movement, is your heart rate relatively stable, or is it jumping all over the place? Stability suggests your muscle pumps and respiratory pump are online and doing their job, supporting the heart.
Interesting. So less volatility is good. What else?
Look for efficiency over time. Let's say you do the exact same 20-minute wave session today and then again in 3 weeks. Is your average heart rate lower the second time, even if the movement felt similar?
Doing the same work with less cardiac cost.
That's measurable improvement. Better stroke volume, better pump assistance, or both. And third, look at your recovery rate. After you stop the session, how quickly does your heart rate drop?
Like that number people track beats dropped in the first minute.
Exactly. A
Yeah.
quick drop, say 25, 30 beats or more in that first minute, is a great sign. It shows the stimulus was challenging but sustainable, and your respiratory system is effectively helping manage the recovery process.
So optimal conditioning isn't about feeling wrecked. It's more subtle.
It's when the movement starts to feel easier, almost effortless, even if you're working for a good duration. Your joints feel fluid, not creaky. Your breathing stays relatively calm and deep, even during the activity. And recovery afterwards is fast.
That feeling of invigoration, not destruction.
Precisely. That feeling sustained over weeks and months, that's the true sign of positive adaptation across the whole augmented system.
Okay, so wrapping this up, the big idea is circulatory health isn't just about the heart muscle. It's about coordinating this whole augmented system. Heart, muscle pumps, respiratory pump, joints, lymph, fascia.
And the key to that coordination is intelligent, varied movement that restores that neural tensegrity control of those cross-lateral connections.
Fascinating. So a final thought for people to chew on.
Yeah, maybe think about this. If you notice yourself compensating during movement, maybe you brace your core unnecessarily. Hold your breath when lifting something, feel chronically stiff, or always move in the same limited ways. Ask yourself honestly,
Ask what?
what intelligence is actually running my system right now? Is it one of adaptation, flow, and harmony? Or is it stuck in a pattern of protection, compensation, and strain?
That's a powerful question. So what does this all mean for us? Stop thinking conditioning is just punishment. Start seeing movement as this ongoing, intelligent conversation with your entire system.
Couldn't said it better myself. Move intelligently.